Welcome to your chemistry class. My name is Dr. Luz Carrillo, and in this video, we're going to start learning about the concepts of Chapter 1, which is titled Matter, Measurements, and Calculations. Since this is a chemistry class, let's learn what is the definition of chemistry. Chemistry is the study of the composition, structure, properties, and reactions of matter. Matter is another word that we can use for all the substances that make up the world. Chemistry is an important subject because it is the foundation for many other scientific disciplines, which includes and is not limited to health sciences and environmental sciences. Additionally, some of the chemical concepts that you will be learning in this class may show up in some classes that you have to take as part of your curriculum, which can include microbiology, nutrition, and physiology. The main goal of this class is that you learn that the world around you has many concepts that are attached to the study of chemistry. Additionally, when it comes to your future profession, you will see how chemistry is present in it. As I mentioned, in this chapter, we're going to learn about matter. Let's first learn what is the definition of matter. Matter is anything that has mass and occupies space. Those two parameters must be measurable for something to be considered matter. When it comes to the measurement for the occupation of space by a particular substance or an object, understand that we will be measuring its volume. When it comes to the amount of matter in a particular object or substance, then we are referring to its mass. Maybe you have mentioned in everyday life how I am just measuring the weight of this object. Now, let's understand that mass and weight are not the same thing. Because when it comes to measuring the amount of matter, the correct term to utilize is mass, because specifically weight refers to the measurement of the gravitational force acting on an object. So in the laboratory, whenever you are recording the amount of matter for an object or for a substance, what you are recording is its mass, not necessarily its weight. Matter can be classified based on its composition. The first classification of matter that we're going to learn about is pure substances. Matter that is considered a pure substance is going to have a constant composition and fixed properties. There are two subcategories for pure substances, starting with elements. We're going to learn a great deal about elements in this class, as all of the information for elements, it is stored in the periodic table. You will see in later chapters how that comes in handy. An element is defined as a pure substance consisting of only one kind of atom in the form of a homoatomic molecule or individual atoms. If we look at the images on the top right corner of the slide, we can see examples of elements. If first we focus on these three, charcoal, graphite, and diamond are a representation of the element carbon. The symbol for carbon is a capital C. Next to it, we can see an image of a pile that looks like a yellow solid. That is referring to yellow sulfur. When we find sulfur as an element in nature, we see it as a homoatomic molecule. And that's because we see the symbol for sulfur being S, but then in the bottom right corner of that letter S, we see the number 8. As long as you have a value of 2 or more next to the chemical symbol for an element, that is considered a homoatomic molecule. Elements can come together and be chemically linked to one another to make what we know as compounds. Compounds are also pure substances. They have a definite composition. And as I just mentioned, because we have different kinds of atoms or elements coming together and being chemically linked to one another, meaning that they're going to have what we call bonds. We're going to learn about this in later chapters. That's what we know as a heteroatomic molecule. Let me introduce to you a compound. So, for example, water is a compound because when we look at water, water is composed of two hydrogen atoms and one oxygen atom. So, when we show it in terms of the chemicals present in water, that's why you see H2O representing water. Now, how are these atoms linked to one another? I'm going to show you the representation that we use in chemistry for water, which is the oxygen. There's lines coming out of it, and then you see the H's representing the hydrogens. Additionally, we put these dots on top of oxygen, which are called lone pairs. In later chapters, we're going to learn how to draw this in other molecules. But for now, just note that specifically these lines that you see here, I'm going to highlight them. These are representing the bonds that are chemically linking the two hydrogens to the oxygen atom in water. If the classification of matter is not a pure substance, then it must be a mixture. And when it comes to a mixture, mixtures are composed of chemically distinct components that do not react. They are just physically mixed. Mixtures can be subcategorized into first, a homogeneous mixture or a heterogeneous mixture. Let's define what is a homogeneous mixture. When it comes to a homogeneous mixture, this is going to be matter that has the same properties throughout the sample. We also use the term solutions to describe a homogeneous mixture. So at times you will hear me use the word solution to describe a homogeneous mixture. Let me give you an example. Here we have sugar and water. And if at home you're making or you're putting sugar in your coffee, in your tea, or if you're making Kool-Aid, for example, you know that when water and sugar mix, all of a sudden it looks like a uniform distribution of those two substances. The same properties are observed throughout the mixture for the substances that are present. So when we look at homogeneous mixtures, they look uniform and we cannot distinct all the different components that are in there. In this case, we just have a two-component mixture, which is just sugar and water. If you can identify each of the components for a mixture, understand that then what we're referring to is a heterogeneous mixture. As you can see by definition, a heterogeneous mixture is going to be matter that within the properties of the mixture, they're not going to be the same throughout the sample. So to give you an example of a heterogeneous mixture, here we have sand mixed with water. The mixture that results from there, you can identify what is the sand and what is the water. So since we can see the different components, heterogeneous mixtures typically are not uniform. And that's why you have different properties throughout the sample that you have. To summarize the classification of matter based on composition, we have the following slide. We can observe that matter can be classified as a pure substance, and those pure substances can be an element or they can be a compound, and we have examples. If matter is not classified as a pure substance, then we are classifying it as a mixture. And mixture can be further classified as heterogeneous mixtures or homogeneous mixtures. Let's now talk about properties and changes. Properties are going to be specifically things that can be observed and things that can be measured. Physical properties are going to be those properties that can be observed and can be measured, but they do not change the composition of the matter that you're trying to study. So, for example, looking at a color of a substance or measuring its length represents physical properties. Chemical properties are going to be properties of a substance that describe its ability to change into one or more new substances. And these things can be observed and they can be measured. Examples of chemical properties include acidity and reactivity. Matter can be found in different states. The three different states of matter are going to be solid, liquid, and vapor. Another word for vapor is gas. When matter undergo changes, we can classify it as physical changes versus chemical changes. Physical changes are going to be specific to changes that matter is going to undergo, but it's not going to change. It's not going to change its composition. The only thing that is going to happen is that heat energy may be added to the matter to change its state, or heat energy is removed from the matter in order to undergo the phase change or the state change. Let's look more closely at the terminology that is important in figure 1.5 that describes the different changes in state for matter. So when we zoom in, we can see that the orange arrow is going to represent specifically all the different changes in state of matter that heat energy is added to the matter. So if we have a solid changing all the way to a gas, that is known as sublimation. If we have a solid changing to a liquid, that is known as melting. If we have a liquid changing to a gas, we know that as evaporation. Let's now discuss the state changes that happen when heat energy is removed from matter. Starting at the end of gas, if a gas is changed all the way to a solid, that is known as deposition. If a gas goes to a liquid, that is known as condensation. And if a liquid goes to a solid, that is known as freezing. It is important that you know those terms from figure 1.5. And let me just say that when it comes to physical changes, state of matter, or in other words, phase changes are always physical changes. Let's now discuss chemical changes. When matter undergoes a chemical change, it involves changes in its composition. In figure 1.4, we have an example of matter undergoing a chemical change. Let's go through the different images. This chemical change is specifically for the element magnesium, which its symbol is Mg. This is a pure substance. When magnesium metal is taken and then it is ignited with a flame, magnesium burns with a really bright light that you could see it right here. As a result, what is happening is that Because magnesium was ignited and it was done in a room where there's air, the oxygen in the air mixed with that magnesium, and it created a brand new substance that we know as magnesium oxide. And we can observe if we look at magnesium in the beginning versus magnesium oxide, both substances are going to have its own chemical properties, its own physical properties. To note if a particular substance has undergone a chemical change, you can see in the following slide different possible indicators for chemical changes. Some of them include the release of energy, the formation of bubbles, because in the change we have a gas that is formed, the permanent or unexpected change in color, if odor is released, if we have the formation of a precipitate. Understand that the precipitate is another word for the formation of a solid because of a chemical change. If we have changes in temperature, if we have the emission of light, like you observe in the example with the magnesium, all of those are indicators of chemical change.